In topic 4, we're going to finally talk about simplifying rational expressions, which is kind of the heart and soul of this section. So we've already looked at simplifying fractions. Everything we do in this chapter is going to relate back to just plain old fractions. So those steps and those processes that we learn with fractions, they apply here. We just have to kind of incorporate what we know about fractions with what we know about algebra, okay? So for this section, or this topic, we'll say, we have the fundamental principle of rational expressions. So remember, rational expressions are basically fractions where the numerator and denominator are made up of polynomials, okay? So this principle basically says if P, Q, and R are polynomials, and Q and R are not zero. Remember, the denominator of a rational expression can never be zero, just like a fraction can never have a denominator of zero. So if P, Q, and R are polynomials, and we know that Q and R are not zero, we can say that P times R divided by Q times R is going to simplify to just P divided by Q, because this factor of R, it just divides into itself to become 1. R divided by R is 1. 1 times P over Q is just P over Q. Okay, so basically what happens is we need to find ways to divide out common factors within these rational expressions. Just like we did with fractions, we divided out common factors in the fractions to reduce them to simplest form. We do the exact same thing here. It just looks a little different because we have algebra involved. Okay, so steps to simplifying rational expressions. Factor. You have to factor the numerator and denominator completely. This chapter is going to have so much factoring in it that it's almost like factoring plus, okay? So you need to make sure you have done a lot of review and practice with your factoring techniques. So you factor the numerator and denominator completely, and then divide the numerator and denominator by any common factors, just like we did right here. We divided out that R factor that was common to the numerator and denominator. A lot of times you'll see instead of divide the numerator and denominator by the common factor, you'll see cancel common factors between the numerator and denominator. Just remember, when we cancel in math, things don't just disappear. They divide to become 1, or they add and subtract to become 0, okay? So let's go ahead and look at example 4. So example 4 says simplify each rational expression. All right, so looking at part A, we want to factor the numerator and denominator as much as we can. Okay, so completely factor. Looking at the numerator, I see a common factor, a GCF of 3x. Both of those terms have a 3 in common, both have an x in common. So I want to go ahead and write this as 3x times, well, if I take that first term in the numerator, 3x squared, and I divide it by 3x, I'm left with just an x. If I take that 9x and divide it by 3x, I'm left with just a plus 3. Now, if you need to do the factoring like with side work showing your steps, that's fine. Just move over to the side. 3x squared plus 9x. We want to rewrite that as a product where 3x is the GCF, and then show your division. Well, 3 divided by 3 is 1. X squared divided by x is x. 9 divided by 3 is 3. X divided by x is 1. We get that 3x times x plus 3. I will say that as you work through this section, you're going to be factoring a lot. You're going to be factoring as much, if not more, in this section than you did in the previous chapter where we focused on factoring. You do need to get comfortable where you can factor out a GCF without having to do all the side work, okay? Now, the denominator is just 18x, okay? I don't really need to factor it. I could certainly write 18x as 3 times 6x if I wanted to, and then I can see common things that could divide out. Or you can just leave it 18x. It's going to simplify kind of like a regular fraction. Okay, so looking here in the numerator and denominator, I do have a common factor of 3. 3 goes into 3, and it also divides into 18. So I'm going to divide the 3 and the 18 by 3. Well, 3 divided by 3 is 1. 18 divided by 3 is 6. And then notice here, I have an x in the numerator and denominator. That's a common factor that I can divide out. X divided by itself is 1. X divided by itself again is 1. So we could say those x's divide out to just be a factor of 1. Okay? So when I simplify, my numerator is now x plus 3, and my denominator is 6. And this is the final answer. Now, I want to put a little word of caution here. If you look at the numerator, we have terms of x plus 3. Okay? In the bottom, we have a factor of 6. You cannot cancel factors and terms, okay? So you cannot cancel terms. So in the numerator, you might be tempted to try to cancel that 3 and that 6, but that 3 is added to that x. It can't be separated from that x. X plus 3 is x plus 3. It's a factor all on its own. You can't split that factor into two terms and try to cancel them. We can only cancel factors. You cannot cancel terms. You can only cancel factors. And this is a big deal. You need to really make sure that you understand the difference between terms and the difference between factors, basically. All right, looking at part B, we have 2x minus 10 in the numerator. We have 4x squared minus 20x in the denominator. Both of these have a GCF that need to be factored out. So looking at the numerator, I definitely have a GCF of 2. So I want to write the numerator as a product of 2 the GCF and whatever I get when I divide the GCF out. Well, 2x divided by 2 is just x. Negative 10 divided by 2 is negative 5. So that's that for the numerator. The denominator definitely has a GCF. In this case, they both terms in the denominator have a 4 in common. They also have an x. So I'm going to factor out a 4x. Now, when I take 4x squared and divide it by 4x, I'm left with just an x. And if I take negative 20x and divide it by 4x, I'm left with negative 5. Now, if you need to see that, we have 4x squared minus 20x. We want to write that as a product with the GCF being 4x. In the first terms, 4 divided by 4 is 1. X squared divided by x is x. For the second terms, negative 20 divided by 4 is negative 5, and then the x's just cancel to become 1. So make sure you've practiced factoring, because truthfully, you should be able to factor out a GCF without doing the side work. If you need to do the side work, do it, but you do need to get comfortable enough with this where you can just factor out a GCF. Okay, so let's see what we can factor out here. So things that'll cancel, things that'll divide out to become a 1 would be the x minus 5. Now notice we're not canceling an x and then canceling a negative 5. No, 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 no. The x minus 5 is a single factor. That x minus 5, they're connected. You can't break them apart. So the x minus 5s as a factor alone, they cancel, okay? We also have, let me do this in red so you can see it really clearly, 2 and 4 have a common factor of 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So let's see. Let's clean it up. In the numerator, everything has canceled out and we're left with just a 1. In the denominator, we're left with a 2x. So that would be our final answer. Okay, so we're just factoring and we're dividing out common factors. Okay, let's look at the last two examples. So the last two examples, part C, we have x squared minus 4 divided by 2x squared minus 3x minus 14. We're going to have to do a little bit more intense factoring here, okay? When I look at the numerator, I have two terms. And if you remember that factoring flow chart that we've looked at before, when you have two terms, it's going to be the difference of squares or the sum or difference of cubes. Remember, the sum of squares is prime, so that's not going to be an option. And when I look here, I definitely don't have cubes, so that leaves me with the difference of squares. And just as a quick reminder, if you have the difference of squares, you take the square root of those two terms and you add them and then you subtract them. So when I look at x squared, its square root is x. When I look at 4, its square root is 2. So I would say my numerator is going to factor as x plus 2, x minus 2. So that's my numerator, okay? Now, my denominator, on the other hand, is going to be a bit more involved. So for the denominator, we have a quadratic trinomial. There is no GCF, and we have a coefficient that is not 1. That means we're going to have to do that AC method, okay? So for the AC method, you take the coefficient of the squared term, which we always call it A. We take the constant, that's always called C. So A times C is 2 times negative 14, or negative 28. Now what we want is we want factors of negative 28. So two numbers that multiply to give us negative 28. That means one is positive, one is negative, and the two factors have to have a sum of negative 3. Since the sum is going to be negative, that means the bigger of the two factors, the larger factor needs to be the one that you make negative, okay? So we could have negative 28 and 1. We could have negative 14 and 2. 3, 4. We could have negative 7 and 4, and we can stop there. I don't think there are any other factors, but we can stop here because if you look right here, negative 7 plus 4 is -3. So what we do is we rewrite the polynomial. So I'm going to get 2x squared. But instead of writing -3x, I'm going to break down -3x into two terms where the coefficients on those terms are the factors I just found. So I'm going to say plus 4x minus 7x minus 14. And then we do that factor by grouping thing, remember, where we split the polynomial in half and we factor the left and then we factor the right. So looking at the left-hand side, I have a common factor of 2x. That's going to leave me with x plus 2. On the right, I do have a lead term that's negative, so that means my GCF needs to be negative. And I have a common factor of 7, so -7. Now, when I divide -7 and -14, or well, -7x and -14 by -7, I'm left with x plus 2. And hopefully you can see here that we have a common factor of x plus 2. So my big GCF is x plus 2. And then that leaves me with a 2x minus a 7. When I divide both sides by x plus 2, I'm left with 2x minus 7. So over here, back to the regular problem, my denominator factors as x plus 2 times 2x minus 7. Now let's see what we could cancel. Well, when I look at this, the top and bottom both have a factor of x plus 2. So x plus 2 divided by itself is 1. X plus 2 again divided by itself is 1. Or you could think of x plus 2 divided by itself as just 1. And then we have 1 times x minus 2 over 2x minus 7. And that is your final answer. Okay. So last example here, we have x cubed plus x squared minus 3x minus 3. Well, if you go back to that factoring flow chart, we looked and we have a column for what do you do if you have a binomial, what do you do if you have a trinomial, and then if you don't have a binomial or a trinomial, you just factor by grouping. So since we have 4 terms here, we're going to factor the numerator by grouping. Luckily, the denominator is a quadratic trinomial, and the coefficient of the squared term is 1, which is going to make that factoring a bit easier. So let's go to the side and look at the numerator. So remember, factor by grouping, we split it in half. We factor the left, we factor the right, and then we factor overall. So looking at the left, I have a common factor of x squared. Well, when I divide these two terms by x squared, I'm just left with x plus 1. Looking at the right-hand side, I have a lead term that's negative, so my GCF needs to be negative, and the common factor is 3. Well, -3x divided by -3 is just x. -3 divided by -3 is just 1. So far I'm left with x squared times x plus 1 minus 3 times x minus, or x plus 1. I forgot my plus sign. Okay, so the common factor here is the x plus 1. So my GCF is x plus 1, and that leaves me with x squared minus 3. So my numerator is x plus 1 times x squared minus 3. Now, the denominator is a quadratic trinomial, and luckily the coefficient of the squared term is 1. That makes it like the easy shortcut factoring. So we know it's going to factor as the product of two binomials. Now, what we need for the second one is factors of -2 that have a sum of -1, okay? So factors of -2, we could have -2 and 1, or we could have 2 and -1. Now our sum needs to be -1, so the larger of those factors is the negative, so we're going to stick with -2, +1. So when I factor, I get x plus 1, x minus 2. So now the numerator and denominator are fully factored. We want to see if we have a common factor top to bottom, and we do. We have a common factor of x plus 1. So x plus 1 divided by itself is just 1. And that leaves me with x squared minus 3 all over x minus 2. Now, the x squared minus 3, you always want to take a glance at something like that. It's 2 terms. You can see the first term is definitely a perfect square. The second term isn't, so this isn't going to factor any further. So that's your final answer. So I said this earlier in the video, you need to know how to factor, period, for everything in this chapter. Everything we're going to do requires factoring. So you're going to factor in this chapter the same amount, if not more, than you did in the previous chapter. So make sure you take some time to review your factoring, review those factoring techniques.